I will briefly talk about the anatomy of a Spring Boot microservice, just to get the keyword and vocabularies. I expect you to have a previous experience with Spring and Spring Boot, so it's intermediate level, I would say. Then I will explain the persistence layer I used for my demo. I do the demo with you with REST, Grpc, GraphQL, all about source code, real stuff. And then I can discuss a decision tree. Everything that you will see today will be available for you. I will give you the slide, the code, everything's available on GitHub. And in a few minutes, I will share the link with you. You could even do the demo with me if you pick the correct GitHub repo. Okay, let's get started with anatomy of a Spring Boot microservice. Microservice, maybe you probably know already, but let's see. In the 20th century, we used to define application as monolithic. Some people keep doing that, where you expect to have somewhat user interface, business logic, and data interface, but in reality, this is just a mess. It's a spaghetti where you don't know how to organize your code. So at some points, one architect draw his sword and start to slash this monolithic application. And so we add layers. Now the front end has its own runtime user interface, the backend as well. You can start to split business logic to interface to data. But at that time, it was still only database RDBMS, relational database management. Either OLAP, real-time queries, OLTP, real-time queries, or OLAP, analytics, like data warehouse. So then again, with the sword, we now split vertically. Some calls that the digital transformation. I don't really like this name. It's too marketing-ish to me. I'm more kind of a technical guy. So first, on the UI part, you are now multi-channel, web UI, mobile UI, internal UI for portals, and the services, you need to reuse them. And this is the era of what we call SOA, service-oriented architecture, with middlewares or architectures like ESB, Enterprise Service Bus, just to be able to reuse these services. And it's also, I would say, 2005, 2010, where now we also change the databases. It's not only RDBMS, but also NoSQL, if your data cannot fit in a single server anymore, or you do have too much throughput capacity volume, and data lake, because now data mart are not enough, where RDBMS is not enough. And here we come. Nowadays, all things distributed, okay? Everything is split into even smaller pieces. And the next iteration is, of course, function as a service, where again, we were able to split again more. But for today, let's stick into this representation. At the front-end level, it's not only a UI for mobile, a UI for web. Now, inside the UI, you have dedicated component, web component, that you can embed in either interface or the other. You do have a thin layer, backend for front-end. Most of the time, it's an API. And so you might decide if also Spring Boot could be there or not. So I will tell you about that. And at the microservice, this is really what used to be the backend. You do have one runtime per business context and have multiple small functions in there. The main important concept is to split by business domain, just to have autonomous and standalone runtime for each microservice. In this ecosystem, there are new middleware tools like a proxy in front of your API named API Gateway. In the proxy, you can delegate security, monitoring, throttling. You can also delegate the tracing to distributed tracing tools, Grafana, Prometheus, and all that stuff running in containerization. So why I show you this picture? I show you that because now, in my perception, inside a Spring Boot app, our microservice, you only need to focus on your business logic. And I will explain how I split the business logic inside a microservice. Also in the database, quickly, you can see that there is even more diversity in the database field. And now each database fits some use case and not others. And as the microservice is quite small, you can attach one database to a set of microservices that are relevant for this use case. Let's move to the SpringBoot microservice. Okay, this is my runtime. And my SpringBoot microservice will be specified by the way I need to access it. This is what I call the access pattern. Based on the volume, the throughput, the latency, the security constraints, and more, I will decide how I want to implement my microservice with SpringBoot. SpringBoot is just the skeleton. I do have a lot of modules I can use within SpringBoot to shape my project. The keywords for a SpringBoot microservice are controllers, service component, and repository for the persistent layer. SpringBoot also provides extra capacities like configuration, monitoring, and security. But as I will focus mostly on API implementation, I will stick to persistence and exposition. But hey, even there, you can see that depending on what is the volume, I mean, if I do 1 million records to answer per second, I probably have also to pick the proper database to have these huge throughputs. So, and depending on the volume, you will pick also either kind of API synchronous or asynchronous to get as much performance or volume as you need. Okay, so if you already used SpringBoot to do a microservice, the vanilla approach is I define my data model, a few tables, maybe some relational database. Okay, I define the repository using Spring Data, and I expose using Spring MVC, Spring Data REST. So the connection between the repository and the database is done with a driver, and then Spring Data does everything for you to move from the tables to the service layer, and there is Spring Data REST that could export that. Okay, Sumaya, you might say, so what? Yeah, that's very easy. We don't need to talk to explain that, right? So let me show you what does the code look like. I create an entity from a table. I create an interface, which is a repository using Spring Data for each entity. As you can see, I use generic. Customer is the value, long is the key, the primary key. And here this is a relational database tables, and I use kind of auto increment strategy from an ID. And if I want to move to API, I simply add a new annotation, and now this is a REST endpoint. Okay. But hey, today I want to build a more deep dive into how to build an API. This is a bit too simple. You need to shape what you want and build custom APIs for you. And the issue with this approach is, what do you do when the volume grows, when you need to scale up? I mean, at the database level. Now you may need to create index because there is too much volume in the database, or to do complex join, or even to chart the database. So of course, you still have something called JDBC template in the Spring Data world to help you creating custom queries. But still, this is not the best fit for huge volume. So in a distributed system, you cannot achieve consistency, availability, and partition tolerance at the same time. This is called the CAP theorem. And as your microservices are, in fact, distributed architectures, you cannot really ensure consistency between two microservices, SpringBoot microservice, at the database level that will handle the same data because there is no distributed transaction easy to do. And to do that, I will not use a relational database to do my demo, but I will use Apache Cassandra. And there is no surprise. After all, I'm an advocate for Apache Cassandra. And this is a good reason to show you what is Cassandra, what are the use cases, and build the API for Cassandra. So let's get starting with building persistence layer and data model for Apache Cassandra. Apache Cassandra is a distributed NoSQL database. You can install, because technically speaking, you can install Cassandra on a single node. It works. On a node, you can have up to 1 terabyte of data and 3,000 transactions per second and per core. But hey, it's a distributed database, so we expect you to install Cassandra on multiple nodes, and there is no master in there. It's peer-to-peer communication, and the peer-to-peer communication is called gossiping. And you can group those nodes with something called a ring. Let's call it a ring. So good use case for Cassandra has first the scale linearly capability. You need more capacity, you add new node. You need more throughput, you add new nodes. And companies like Apple, Instagram, Uber have Cassandra running with something like 100,000 nodes. True story. And they deliver 12 petabytes of data live online. The data is distributed. That means even if I create a small tables with a few records to have the cities, we are hosting tables. The data is distributed among the nodes. That is the trade-off, you know. You don't want to have a node holding all the data, so you choose one of the columns, do some hashing, and the data is distributed around the node. So even with this very small database, you can see that it's not a good idea to do select star from this table, right? Yes, and you need to provide the where clause where you put the column in red, meaning here the country. Okay, so that Cassandra is distributed, and each node is in charge of a subset of the data. But you know what? The data is also replicated. The same data is available at least on X node. X is called the replication factor. And now when a client wants to write something into the database, well, if the node is not in charge of this data, it will send the proper data in the X here 3 replica. So data is distributed, data is replicated, and there is no master in there. What it means? It means that I can lose any of the node. If that happened, then I will send the data to the node data up, and I will keep a hint locally. When the node come back online, I can push back the information to it. And this is what we call self-healing database. And this match very well cloud environment when you are running on commodity hardware and you can crash a disk and crash part of your application. And Cassandra is also very useful in those environments. So that would enough with Cassandra. Let's switch back to Spring Boot very soon. But for you to know what is a good use case for Cassandra, remember SARD. S meaning scalability. When you need high throughput, high volume, meaning every read and every writes. Use case, event streaming, IoT, log analytics, any time series. And I'm quite sure that if you already heard about Apache Cassandra, this is in those use cases, big data, streaming layer, when you need to write a lot of data. And because Cassandra is distributed, you can do that. Second is mission critical availability, no data loss. You can lose any of the node. So this is true for any customer-facing application. Monzo Bank in the UK, it's pretty famous to have the full data running on Cassandra. But there are a lot of other companies, Netflix, for instance. Everything that I told you is real-time, and this is also what makes Cassandra very interesting for API real-time layer. Okay, Last but not least, Cassandra is distributed. So I show you a data center, but you can totally create multiple data center inside a Cassandra cluster. And then you can read and write from everywhere. You can have a ring inside your on-premise, a data center in the cloud, and both will communicate in two ways direction. You can read and write from everywhere, and the data will be replicated for you by Cassandra. Okay, now I'm done with Cassandra. Let's go back to the Spring Boot part and the API part. But with that, I need now to create my data model. I will create a CRUD API and execute some requests. So I need my data model. Okay, Cassandra is very fitted for microservice world. I told you it's real-time and scalability at core. I also told you that now in a fully distributed architecture, it's not easy to provide async transaction. It's more BAS, basic availability, soft-stake, eventual consistency, and Cassandra and microservice work the same way. And also you might say, oh, people told me that I should have a database per microservice just to be autonomous. Well, a database per microservice does not mean a database instance installation for each microservice. Because there are other ways to segregate the data. You can segregate by key space, by tables, by query. And as you can see, if you lose any of the node, the database self-healing, well, that's totally fine to have multiple contexts running with a single Cassandra ring. Okay, so if you read the abstract of the talk, you know I talked about Killer Video, which is a reference application developed by my team to show you how to build an application on top of Cassandra. So, of course, we are using both API and a front end. And today I will show you the backend API part because we have implemented the same request in Grpc, GraphQL, and REST. To properly design a data model with Cassandra, you need not only the entities and relationship. This is what we do with relational database when we have only the entity. You also need the application workflow. You will create one table per query, and you will need the application workflow right at the beginning. And same for your API, right? You need to know the queries to start building your APIs, because if you start building an API knowing only the entities, maybe at some points you won't be able to achieve the request because there is too much joins and the database does not fit what you need to. And with Cassandra, no big deal, you need both. So let's show you with a sample. On this Killer Video app, there is a page, it's kind of a clone of YouTube. There is a page when you see the comment each video. And there is another page when you see the comments of a user. So a user can comment a video, and a video can be commented by many users, many-to-many relation. This is my application workflow. On screen 1, I want to list all the comments for a video, providing the video ID, get the most recent first, and have paging. Close request for the user comments. And of course, I need to implement CRUDs. Okay, so I'm using the workflow I just showed you before. So 2 queries, 2 tables. This is how it works. On the first query, I need to list all the comments for user ID. So user ID is my partition key. Remember then red column in the first slide, how I distribute my data. If I do that, all the data related to a user will be hosted on the same node. And when I execute command by user, I got all the command for this user with one request. I don't need to contact multiple nodes. Same for command by video. And I added C for clustering column to ensure ordering my result, and unicity of my result. To a physical data model, okay, this is what it would like. Just note, I shrink the comment ID. It's not very familiar to you because you do have a user, maybe you are familiar with user entity, video entity, create 2 repositories and 2 REST API, but no, this is not how it works. And for some part in your code, it won't work that way either. So having the approach entity repo REST endpoint is not enough. We need to do better. So finally, we have the data model, we have the application workflow, we know that we will use Cassandra, we also know that we want to use SpringBoot, and I told you that we do have Grpc, GraphQL, and REST API. So let's get starting with my demo. Okay, so I will share with you the GitHub repo. So if you are in front of your laptop, you can totally do the demo with me. So this is a multi-module Maven project. I do have a module for each each API implementation, and I do have a common module holding the driver and DAO items. Okay, so as you can see, the URL is pretty easy to go. Is github.com, right? /CLUN, this is my alias, /JavaFest 2020. So if I move there, go to the web, okay? If I move there, you can see that this is a multi-Maven module project. You do have all the code and also the slides for today. You can simply clone the repo and import the repo as a Maven project in your IDE, and you start everything with docker compose.yaml. It can take a bit of time because in the docker compose YAML, you will have to download the Docker image. So here, I do have my project compile, and Docker Compose has been started, and I do have 2 containers running. So this is the Docker Compose file. I have started Cassandra, a distribution of Cassandra, and I do have started DataStax Studio, which is a web UI to interact with Cassandra. So this may take a bit of time to download, but you can simply now do Docker Compose up-d, and you will be in the same settings as me. So as you can see, Killer Video DSC, Killer Video API REST, Killer Video API gRPC, and GraphQL. Okay, so if I go back to the web UI and try to reach DataStax Studio, you will reach this interface. I click on the notebook, JavaFest 2020. Okay, it's coming, it's coming. Okay, and I will drop the key space. So the key space in the Cassandra world is, the same as a schema in the Oracle world. Okay, so now it's not happy. What's happening? Okay. My Cassandra is there and should be there. Let me refresh my studio. Okay. Geez, is this only him? Let me start my REST API. Let's see if the REST API can connect or not. Okay, so the REST API is totally connected, so let's see why the studio is not there. Never mind. So this is a notebook which is not very happy about my connection to Cassandra at the moment. Never mind. I will create my key space, and I will create the 2 tables we just defined together using CQL statement. And I will empty my tables. So I should go there and execute telling me that my table is now empty. Never mind. Let's move really now to the meat of the talk about creating a REST API. Okay, so I'm opening the API REST project, and for the DAO part, there is no mystery. I simply create a repository and unlink the CRUD operations. What maybe you want to see is the exposure. So this is also very familiar. The REST is the easiest and the most common pattern. So I will use the standard HTTP word and the HTTP code and the standard annotation from Spring Web MVC to make it work. And as you can see, I simply invoke my repository. Easy, right? So in my repository, I do have not only the CRUD, but I also created already the different queries. So it's not as stupid as just setting extend CRUD repository. I also have defined extra queries to find the video by ID and the comment by ID. Okay, I do have a resource for video. I do have a resource for user, video by user, comment by video, comment by user. And I also have the comment resource because I will do CRUD with this resource. So what I like with this Spring MVC approach is that you can also annotate your resources to provide documentation on top of your API. So you can use Swagger 2 from SpringFox, or also SpringDoc using the latest version of the specification called OpenAPI. And now if you open a browser and go to your REST endpoint, not only you do have the REST ready, but you also have some tools to test it. Okay, user, video, command. So let's test it. In my IDE, I do have a unit test to generate some data inside the tables. Okay, so my user ID is here. So I can go back to the browser and say, oh, show me all the commands for this user ID. I will try out, provide the user ID, and execute. And as you can see, I do have my commands appearing just here like that. So very easy to do. Simply try it like that. So in a REST resource, it's not that easy to implement paging. I mean, at the repository level, there is some pageable repository. But when it comes to REST resource, what I did is I've created extra parameter in my queries to provide page size and page state. Page state is a long string recorded at Cassandra level to be able to get immediately, page 13. Very useful when you want to do some paging in the web UI. Okay, so what is true for user, I can do the same for video, and I can also create a new comment with the REST UI. Okay, so Spring MVC annotated using Swagger to have the proper documentation and the client test like that. Okay. Again, also the important part today is I will give you this code. You download, you Docker compose up, and you do have this code running for you. The best way to understand the way to implement is to have a working sample. Okay, it was the first implementation and probably the one that most people know. Second implementation I will use is Grpc. So Grpc means Google Remote Procedure Call. So it's RPC. It has been developed by Google, and it's doing serialization, I mean binary serialization above HTTP2 protocol. And so the purpose of Grpc is really to execute requests much faster than having a serialization deserialization of JSON and objects. And so in the gRPC, you will have a proto definition. So here I do have my proto service where I will define my command service with three operation, three RPC operation. Okay, and I will define my object from the in proto as well. As you can see, I define some offset for each field, and I also describe the response. Then I'm using a gRPC Spring module, Spring plugin. The protobuf Maven plugin will, at compile time, take my proto file and generate stubs for, the generate stubs for my services. And each time there are multiple stubs. It creates some synchronous and blocking stub, asynchronous stub with future, and also a reactive stub. So the first path to performance is gRPC. So if I go to the code to start the gRPC server, is really simply having a server, okay, gRPC server, and I will declare each service definition by providing the stub and binding the stub that has been generated. Those port is here 8899. Unfortunately, in gRPC there is no real UI. So what I need to do is to execute unit test for you to see that I can also list the services. So I go there, and I need again my user ID. So my user ID, I use it in the web UI. It should be there. I can reuse this guy and execute my unit test with this ID. And I probably have to, okay, yeah, rebuild. That's okay. Project clean. Not sure why it's not happy. Tuk. Okay, so I've rebuilt the project and I will refresh. And what's missing? I need my gRPC stub because I cleaned my project and now I don't have my stub. So what I will do, I will clean install my project and I will have my stub generated for me with Maven. Okay, refresh. Which is funny because the RPC server bind service is happy. Okay. And now I can execute my, so is my gRPC server still running? Because hey, this is the one I'm actually, yes, it started. This is the one I'm actually contacting. So if this guy is not running, Okay, as you can see, I do list my command from the DB. Okay, and I'm using a stub and a builder to build the client from the stub. Okay, second implementation, gRPC, all about performance. Last but not least, let's move to GraphQL. So let me refresh again. So GraphQL, also known as Apollo in the JavaScript community, I think less in the Java world. I think Apollo is really the implementation for JavaScript. Well, in the GraphQL, there is a single endpoint to address multiple services. So you will define your, again, schema as a file. Schema, what is a query, what is a mutation, what are the objects I will need to use to interact with my GraphQL endpoint. Then I will define some entities associated to this. It's not generated this time. I do have to generate the entities, which are the mimic of my GraphQL. And I do have GraphQL query resolver for query and mutation resolver for mutation, to edit. And I simply have to import the method fitting what I do have in my GraphQL definition file. Okay, how do I get these superclass to do some GraphQL query and mutation? There is a dedicated Spring Boot starter. I mean, there is a Spring Boot starter for everything, right? So there is a Spring Boot starter now for GraphQL, and you do have the GraphQL Java and the GraphQL Java tool. So I will start the GraphQL API. Okay. In the GraphQL world, there is a UI provided for you named GraphQL. And I can go there. Let me find my browser and open now GraphQL. Okay. So here I'm accessing the endpoint of the GraphQL API. And you can see that there is a documentation I can browse. So there is queries and mutations. If I go to queries, yes, I can get the video comment, I can get the user comment. And if I go to the mutation part, I can simply comment a video providing the user ID and video ID. So to execute a command, you will provide a JSON like that, okay? Where you will, if you want to list the get user comment, I do have some auto-completion to help me. Here I do have a get user command ready. So we saw previously that in the comment table for this user, we do have 4 records, but let's pretend I will use paging size 2, just to get the first 2, and providing the proper user ID. So let me go back to our unit test in Grpc just to steal my user ID. Okay, here it is. And I execute. Okay, I will copy that and I execute. And as you can see, I do have 2 records. Which is neat with GraphQL is you can ask for what response you need. Here in the result, I ask both for date of comment and comment. But as I know that they are already ordered in the DB, I can simply ask for comment and execute again the database, the request. And now in the result, I only have what I asked for. So when you're dealing with small bandwidth, limited bandwidth, it makes total sense to just limit the result size by explicitly saying what you need. Simple as that. And as you can see, now I do have something for next page. So if I copy this next page and use, let's say, page state, which is this long number, then if I execute, I will get page number 2. And if I now copy paste this guy, I will get page number 3 if there is a page number 3. I'm not sure if I put 5 or 4 item in there. Oh, no, I didn't copy paste, but you got the idea. Now, by saving and asking the client to get back this paging state, you are able to execute some paging. Okay, so we had 1 last comment, so 5 comments total in the tables. So again, small demo, 3 implementations, providing for you implementing the same service. So now let's take some takeaway from these 3 implementations. Okay, so when I set up my connection to the database, I didn't show you, not part of the menu. When I set up my connection to the database, I can either use Spring Data conventions, so I don't have to create any bin for my Cassandra session. If I provide the proper keys in the application.yml, it's done for me. But I don't really like this approach because you need to know all the keys, and even with automation by your IDE, it's not as flexible as having the object you can manipulate and override as much as you want. Second approach is to extend the abstract Cassandra configuration, and he asks you to implement each, what key space do you use in, what local data center are you using, and this is your call to provide the proper values. But again, there is a limited number of methods you can override, and if you do want to have the full control of your Cassandra session, you will create your own Cassandra session object with a dedicated configuration. Here I use DSC session, which is Cassandra session ++, just to be able to have this nice UI all together for the demo, which was not working. Funny. But here I got everything I need to provide everything in my DSC session, including all the small pieces. This is the implementation I chose in the demo. Again, in the demo, I chose some synchronous requests for each implementation, even if gRPC provide asynchronous and reactive, and REST can also be asynchronous now with the latest servlet implementation. And with the synchronous query, you provide the parameter, you bind the parameter, you execute queries against Cassandra, and get the results, page result. The issue with this approach is you are blocked between the time when you fire the query and execute some result. So now in the DataStax driver and the stack of Spring, you can totally go asynchronous. And so now you get a notification, async result set, when the result is ready. And there is more. Now you can do also reactive. And moving from async to reactive, you might say, oh, it's quite the same. Not really. First, with async, if you try to do multiple call in async, you get nested call, and it's pretty hard to debug, to be honest. This is what we call the callback hell. Whereas in reactive, now the API, it's very look like what you would do with the synchronous. And not only that, now for a query you execute, you get a notification not for every page, but for every record. And so you can totally distribute the read of the request on multiple readers. And finally, you get a notification when everything's done on complete notification. And there is a pre-implemented back pressure mechanism at Cassandra level, at the driver level, just to be sure that you can keep up. Builder cannot read all the notification coming from Cassandra. We can slow down the throughput just for get you time to read what you need to. So again, for performance. All right. You see the demo. You see that we could also do reactive and async in some case. So let's define a plan together. You should use what. So we do have the conceptual data model. So in this, you can consider cardinality, versioning, confidentiality, atomicity. On the application workflow, filter, paging, sort, throughput, latencies, all the criteria I gave you. Now, depending on the database you pick, because you need a high throughput, high volume, for instance, you need to ensure data integrity, caching, pick sync versus async. Okay, but not only that, it's not only about technical implementation stack. You also need to consider your users, people that will invoke you. Maybe some people are very familiar with REST API and JSON, and you need to provide code first or schema first, package some client for them, provide test tool for them, and proper documentation. As you can see, for REST and GraphQL is nice. For gRPC, yeah, it's not that great, but on the contrary, for gRPC, if you do have the proto file, you can generate the stub in multiple languages. So it's a trade-off. And also, depending on your consumer, you might, depending on the experience and profile and the technology they are familiar with, it's not the same. So first approach with all the criteria, if I were my big guru technical architect, I will create a very serious analysis matrix, providing some coefficient for every capability we just see there, and I will create this decision tree. I can see you laughing behind your screen. That is expected, man. There is so much criteria that a full decision tree is no use. And for each person, it won't be the same weight for the criteria. So instead of providing you the decision tree, I will give you my recommended path. So first, for REST. REST is very nice to decoupling client and server. This is, schema on read, and you can simply have a JSON with a lot of element. In the URL, you can do versioning. So for API lifecycle, this is very easy. You can do v1, v2, v3 best practice if to have the major version in the URL, and minor version you don't have to provide to, or you can using a field in the header, but with minor version, it should be backward compatible, so you shouldn't do have. And for REST, this is the technology with the most tooling out there. Documentation, client generation, proxy, API management, serverless. Everybody talk REST because it's easy to interact with, and it's still ensuring the decoupling. But REST is not everything. REST have a drawback. Payload are still verbose. Okay, it's not SOAP as we used to have, but still JSON and obviously XML added a lot of extra characters for getting the answer, and each time you get the full payload because you're interacting with object, and if the object is in the response, it will be fully serialized for you. There is no discoverability. There is a format that can be exposed, as a swagger.yaml generated for you. But people in front of a REST endpoint without this contract, they just are stuck. They have to try in the URL if they see something or not. So that's not very easy if you don't provide documentation. And it's really not for function. I don't want to execute an order. It's not RPC-like. It's really the resource. I want to access something. So that's very nice for CRUD. And this is probably the reason why Spring Data REST, using REST for this CRUD. Okay, that's it, very nice. It's relevant for OLTP mutation, edit, create, and for public and web API. Something public, very easy to use, but you need to provide the proper documentation. gRPC now. Main purpose is high performance. As I told you, the payload is binary serialization based on protobuf, leveraging HTTP2 and the multi-payload multiplexing available with HTTP2. There are multiple stubs, synchronous, asynchronous, and streaming. You pick the one you like, and you can generate your stub in multiple languages. So full disclosure, in the killervideo.com application, the one I show you today, we used gRPC because this sample application is implemented in Python, Java, C#, Python, G#, and NodeJS. So having the gRPC schema and generating the 3 server was very easy. But again, gRPC is not fit for all. It is strongly coupled. So yeah, you provide proto and you need the proto.c as a client to be able to interact with it. There is no discoverability whatsoever. Again, you need the contract. And protobuf serialization is not that easy. If you saw in the proto.c, it's easy, but it's maybe too simple. you will define field one after the other. But what if you need some structures, nested structures, like a full document to be passed through? It's not that easy. And you define, 1, 2, 3, which are the offset of each field. And if you miss one of those, yeah, how do you create a new one? It's not that easy. So gRPC is good for distributed network of service, and this is why it has been created at Google. High throughput, streaming use case, and command like. Now it's RPC, so remote procedure call. This is like invoking a stored procedure out there. It's really, I would like to execute an algorithm. And Slack chose this gRPC approach. And now also Netflix fully embrace gRPC, but mostly because the distributed network of service. Okay, last but not least, as you can see with GraphQL, everything is nice. You do have the GraphQL with discoverability, documentation. You can have your custom payload, matching standard both JSON and HTTP. So easy for people to consume your GraphQL. So easy to have a custom payload when you are mobile or web UI to get only what you need. Hey, but wait, it's not magical. There is a single endpoint, so no real versioning. And how do you do the monitoring for each service invoke? It's a single endpoint, not that easy. The implementation for the Java part, as least, is still young. I mean, you can hit some issues, and it's all about Jira ticket. I know for JavaScript it's mature. For the Java world, it's not that easy. But most drawback is it seems to be nice for customer. I can, list all the group of my user, and it's a single query. But under the hood, if you did the wrong mapping with the GraphQL, now you will execute n+1 select queries, and it will be slow. So it's good, for backend for frontend, and backend for frontend, but not for all use case. Backend for frontend, aggregation when volume matters, but not everywhere. Okay, I'm done. As I told you, I give you all the repo, all the materials, including these slides. If you like the content, we do have a YouTube channel. And as you can see, we also provide content in Russian-speaking language. Like yesterday, we did a full Cassandra Day Russia. You don't have to install anything. You just go there, and we provide you an instance on the cloud. And I promise you some sample codes, and I know you love sample codes. I do have here not only gRPC and GraphQL, but also Kafka, Webflux, and serverless. And last but not least, if you have questions, go to community.datastax.com. I'm happy to answering any question. And this is my Twitter handle. And I can now go back here for questions. I'm a bit late. Sorry about that.
It's okay. Thank you very much, Cedric. It was very practical. And yes, we love sample codes. You had a lot of them today. Thanks a lot. So guys, if you have any questions to Cedric, we have just a couple of minutes to read questions from the chat. So please type your questions in the chat, or you can join our Q&A Zoom room right now, right after the talk, and ask in person. So let's wait a minute if any questions appear in the chat. Meanwhile, just some organizational information. After this talk, we will have, you can join, of course, Zoom rooms, and then we will have a big break until 2 p.m. Kiev time. And at 2 p.m. we will be back with next talk. You will also have some time during break to register to prize draws from our partners. You have links to all prize draws just in your participant page. So please register, please join, and I remind you that you can register for prize draw from Svitla company only until 4:30. So any questions? And we are also running out of time. Okay, Cedric, thank you very much. Now, please, you also have the link to our Q&A Zoom room. So I'll see you there, yes. And hope our audience will join us, and we will continue the discussion with with questions.
Yeah, don't hesitate. I do have a lot of content for you. Thank you for having me, guys. See you next time.